Same thing here. It's our oxygen connected to methyl group, so as I saw in oxygen. So same for these two. These are the same. Because look here, saying oxygen, look to the left, saying methyl groups of citrons. That's why it's a 3, 2, 2, to these two, and 3 ratio. And the reason why for this one, it's all different. This is going to be tricky. So let's say, look at this hydrogen. Look left is an arc. It's not symmetrical. See, this is symmetrical. You cut in half. Symmetrical. But this one's not. So this hydrogen is connected to a oxygen and methyl group, and here's a methyl group. But for this hydrogen, it's connected to, you know, this weird thing and another hydrogen. Whereas this hydrogen connected to different hydrogens. This one's a methyl group and a hydrogen. So all these are different. And same thing apply to this. All are different because it's not symmetrical. That's why finding the symmetry of the hydrogens, the molecules, is very important. And you also have to recognize the fact that you see these two molecules, their ratio, hydrogen ratio is exactly the same, but this is different. This is butanol, this is pentanol, so it's different. And later on we're going to see, and you see how this has like, but then these oxygens, how do you say it? The shift value is going to be different because this hydrogen connected to a carbon, this hydrogen connected to an oxygen, and more about that later. So similar, and you know, with this and a carbonyl group, an ether and a, you know, carbonyl group, a ketone. So when we went over all these are actually like most basic common example you might encounter on the exam. My way of showing you these first instead of the graph is because like it's like almost teaching you in a reverse way. Instead of seeing the graph and guess what it is, I show you the answer first and see how help you to imagine like what a graph would look like, by showing you the molecule. So you have to recognize, you have to able to, all these 3 slides just trying to teach you how to recognize unique hydrogens, commonly seen uniqueness of the molecules. So like I said, one like big thing about hydrogens, like when you have a molecule with like a alcohol group, is the protic hydrogens. Protic hydrogen means like it can form hydrogen bonds. Because the fact that it can form like hydrogen bonds in the solution, usually like the peaks are really broad. So broad means like really wide. Just remember this. It's like a trick that you should remember. So let's put together our very first example. So first we need to identify unique hydrogens. So if you look at this molecule, it's symmetrical. That's why these 2 hydrogens are the same. These 2 are the same because it's symmetrical. And ask me if you don't know why it's symmetrical. You just text me. Let me see what you say. just told me you. Okay. Alright, so type A hydrogen, type B hydrogen. So it's 3 to 2. So it's 3 to 2. Notice that it's not like A, B, B. It's just A and B. So, and you also need to notice that A is closer to original point, and B, it's further away. When it's like further away from 0 parts per million, we just call it like downfill or like downshift and whatever. So it's really easy. And I'm gonna explain how like we get like 3 here and like 4 here. So A is representing this thing right here. So it has 3 peaks. It doesn't mean it has like 3 hydrogens. No, it means that its neighbor has 2 hydrogens. So basically how you get 3 spikes is that you look at the neighbor hydrogen and plus 1. See, 2 plus 1 is 3. And if you were to look at CH2 and you look at its neighbor, it has 3 hydrogens and plus 1. It should give you 4 spikes. That's how you have 4 spikes. Okay, and one last thing about like parts per million. Why is it like further down? It is because B hydrogens are closer to the carbonyl group, and carbonyl group has like lone pairs, so it affects the it affects the magnetic field of these protons. Therefore, we need a stronger energy, which means that stronger electromagnetic radiation in order to excite these protons, then we get a signal. So downfield means next to it has something that affects the electromagnetic radiation. It needs higher. Later on we're going to have a chart to show how different functional group and how it affects and how it gives you like specific parts per million values. So this is an example. I just told you how to do it and put together, and the follows are like different, explain all over again, which I would do in the next video because if it's too long, it takes a long time to upload. Okay.